and so CityGML is a part of my talk today. And I'm also chairing another open source project, which is called the 3D City Database, which I will also showcase in my slides. Okay, well, the talk is basically organized. I always will pick one part of my title and go into more detail on that. And so first, motivation, what are 3D city models? And yeah, I thought before having a long lecture about what is it per definition, I just show you how we use them and what we do with city models. So what you see here is the city model of Berlin. And basically, the city of Berlin is using the model for city marketing and as a 3D city information system. So this website is public to the citizens. They can explore the city. We have a lot of information associated with the single objects in the city. You can query the model. You can do routing and things like that. Things you know from a 2D map as well. So Berlin happened to be one of the first CityGML models in the world and is still updated regularly. Another use case is 3D analysis and what if scenarios. So this is the 3D city model of Rotterdam. What we did here was a building energy assessment analysis on top of the 3D models. So we wanted to know where is potential energy savings in the city, what measures can we do on buildings like refurbishment measures in order to save energy. And then we used the 3D model, first of all, to do the analysis, and then, of course, also to bring the results in such a viewer and to help people understand the situation. Yeah, similar. This is the solar potential analysis done in 3D, so not only on the roofs, but also on the facades. And the results of the analysis are brought back into the model. So we enrich the model with the simulation results, and then, of course, can also visualize it in a browser. Of course, we can also link spatial data sets, so existing 2D, 3D information that is available. This is City of Hamburg and street noise. And this is a WMS, which we just feed into the scene in order to render it together with a 3D city model. Yeah, very important for most cities currently is to go underground, to see the utility networks, pipes, electricity, fresh water, wastewater. This, again, is Rotterdam. And what they do is they also have the trees and the root volumes of the trees, and they do clash analysis between pipes and root volumes in order to understand, can we plant a tree at that spot in the city, or will that be a problem in 5 to 10 years? So one use case. And of course, one of the driving factors is urban planning, so you can showcase to citizens or internally scenarios how the city might look like. This is Berlin again. Airport Tegel is currently redeveloped. It should be a business park in the future, and these are first plans how that airport area could look like. Okay, what else do we do? Urban simulation is a very hot topic. We use the 3D city models in simulation systems, for example, in order to understand wind field in the city, pedestrian comfort analysis, or turbulence simulations for single new planned buildings. Smoke dispersion, so that might be toxic gas over the city, so it's important to know where will it be within the next 30 minutes, or blast simulation, flooding. These are important topics. So just to showcase you and give you an idea why 3D city models, why 3D, why it makes sense to use them, to build them, to have them. And yes, based on open standards is the next item I highlighted in my title. So we use CityGML in order to store and manage the models. Who has heard about CityGML, or better, even has used it already? Okay, not too many hands. I expected that a little bit. Let me tell you a little bit about CityGML. So what is CityGML? It's an international OGC standard for semantic 3D city models. Semantic is quite important. I will show you in the next slide why. You can represent all the relevant topographic features in your city with that data information model. So it's not just the building, it's also natural phenomena like vegetation, water bodies, terrain, of course, traffic, bridges, tunnels. You can represent with that data model. It is ISO 19100 compliant. It's extensible, so you can add your own feature types if you miss something in the standard itself, and it uses GML as exchange format. And focus lies on representing objects with 3D geometry, 3D topology, semantics, and appearance. And so that's roughly what it is. And why should we use it? We put really a lot of effort in the semantics of the model. So it is not just a geometry mesh, which renders very quickly in your browser. It also keeps all information about a feature and the decomposition of a feature. So building knows it is decomposed into wall surface, and the wall surface knows it has a window. So this is very important. We have a semantic hierarchy describing the features and how they are composed. And on the other hand, we have the geometry hierarchy, which is tightly coupled. And so we can have basically queries in both hierarchies. And that's, in the end, required in order to do analysis, simulations, like I showed you in the showcases at the beginning. Okay, so that's very important, and that makes a difference to purely graphics formats, or, for example, Bing Maps, Apple Maps, Google Maps, whatever you have there. We have an LOD concept in CityGML. It's similar to graphical LODs, but it is not only enriching of the geometry representation of a feature, it also enriches the semantics. So with higher LOD, the semantic of the objects enriches as well. And you can represent each and every city object within these 5 different LODs. And for urban planning, this might be sufficient. For analysis, LOD1 might even be sufficient. And of course, it's also more costly to acquire buildings in that high LOD, whereas LOD1, LOD2 can be acquired easily. Okay, so here's a City of Marseille CityGML model, and you can see all the different feature types which are available in order to describe the city. CityGML is a standard since 2008, so it's quite mature and stable. Last release was in April 2012, and currently the SWIC in OGC is working at version 3.0, and it has quite a growing user base already. Yeah, this slide I took from OGC, and I think I don't have to tell you, but I like that. So why open standards in general? So standards are like parachutes. They work best when they are open, and that's also the idea behind CityGML for 3D city models. A world map, and that's why I said I was not really surprised of not having too many hands up when I asked about CityGML. We really have a high concentration in Europe, so the bigger cities use CityGML in order to store 3D city models. And currently, really big activities in the Middle East and Southeast Asia. Yes, US, we have something, but not too much, so it could be better here. Okay, so that was CityGML. Next thing is web-based management using open source components. So now you have CityGML as a data model, but how do you manage it? And for that purpose, we have that open source project 3D City Database. It's basically a spatial database in order to manage CityGML data. And so it is based on or implemented on top of Postgres, so the 3D functionalities which are available in Postgres. And we have also an implementation based on Oracle. And we have database tools in order to load the data into the database and to get it out as CityGML or as visualization models. KML, Collada, GLTF is supported with these open source tools. Yes, so this is basically an architecture diagram. So we took the CityGML data model, which is UML-based, translated it in a relational schema, which we implemented on top of Postgres and Oracle, and then we have these tools in order to load and extract data. It's quite mature also. So first version was in 2005. Now we are currently at version 3. So almost 10 years the database has been developed and it's stable. And it is in production use in many cities worldwide, of course mainly Europe, but Singapore currently. Singapore has a huge 3D city model project going on. They are also using the database. In Germany, we are storing more than 50 million buildings in one database instance based on Postgres, and so it works really cool and fast and very well. Okay, web-based management. There is also an OGC web feature service interface, open source for the database, which lets you basically query the objects independent of the relational schema. And we also have a transactional WFS. This is currently not open source. This is a development from my company. But at least the important thing is that we have that interface for the client. You don't need to talk SQL if you don't want to. You can talk OGC WFS in order to query the data, interact with it, update or delete it. And so you can define vendor-neutral processes and workflows on top of your city model. Okay, and that brings the web-based data management to it. And of course, then you can query your model, and since the model knows what is a building, what is a tree, you can basically ask for all building within a distance of a certain point. So we are doing a distance within query here. Yes, and then you can retrieve the features and bring them into analysis or simulations or whatever you want to do. Okay, and now the connection to the talk before and the great developments that are really done with cesium and the 3D tile specification. So what we added to the 3D city database ecosystem is basically a web-based visualization, open source, and it is using cesium as the technology in the background. So what we have on the one hand side is now the database, and that's tools in order to load the data to get it out. And what we added is basically an export functionality to KML Collada, but more importantly to GLTF 3D tiles. So you can export that from the database. And having that, you can bring that into the web or on any handheld device based on cesium. And so this is we call it the 3D City Database Web Map. It also has a very, very easy client which you can use in order to enhance it or build better applications on top. Okay, that's for the visualization. And in order to really connect to the real geodatabase in the background, we then have the WFS in order to make live queries from the web map, or even you could use the map in order to edit and update the model. And of course, with the same OGC service interfaces, you can bring in arbitrary WFS, WMS data sources that you might already have, as I showed you in the beginning. So this is what we added. And right away, when 3D Tiles was available in August, we started our implementation on top. And we released first products. So the city model of Berlin is already available as a 3D Tiles representation or visualization model. And I show you the URL in a minute. Okay, and you can use that entire ecosystem now to build your own 3D city model apps on top. So much is available as open source. You only need creative ideas to use now models and do applications with them. Okay, shortly on the 3D City web map. So that part of the open source project. So it allows for streaming of arbitrarily large CityGML-based models. It's open source. It's based on cesium. It allows to add 3D object layers. You can interact with the objects, hide, show them, highlight them. You have cloud-based access to object attributes. And tile-based loading is not using the cesium implementation. It's an own implementation. The reason is that we want it still to be compliant with Google Earth. So you can still even use Google Earth as a rendering platform if you want. But more and more, we will switch completely to cesium for that. And it's really easy to use. Simply have the database, do a GLTF export, use the 3D City web map client, load the exported data in, and you have it as a 3D visualization. There are demos available on GitHub. So the entire project is on GitHub. This is New York, not the OpenStreetMap 3D data. That's CityGML data, which was created from open data from New York. And it not only has buildings, it also has traffic areas and green areas. So a lot of information, a lot of attributes associated with all of these feature objects. Okay, the virtual city map, this is something we do at our company, goes a little bit more beyond the 3D web map. So we have a full implementation of the 3D tiles. So we support the batch 3D models, which you have heard in the first talk. So we have all the attributes with the objects in the visualization data. We already support the point clouds and the instant 3D objects, which is very important to really render a lot of trees or city furniture, like street lamps or something in the city model. And what is, of course, important for us, because we have that CityGML background, we want to have the semantics of the objects. We want to, if we click on a building, we want to see that the building knows it has a window, and we want to see the attributes of the window in addition to the attributes of the building. So the current layout of the batch table, as we found out, has not really support for that feature hierarchies. So this is what we opened an issue for that, and we are in close discussion with cesium, and in order to see whether this can be part of the spec or whether this is an extension or yes, but this is something we need. And yes, some examples. So this is Berlin city model. So what Patrick already discussed before, we use the CityGML LODs also. So if you zoom in, we load higher LODs of the buildings than those in the background. So this can be really easily implemented with 3D tiles. So 3D tiles is very, very easy in order to do such visualizations and to prepare the data for that purpose. Yes, you've seen that screenshots. Basically, if you click on a building, then this building knows its attributes. You can't read it really, but it also knows, this building knows it has building parts, roof surfaces, wall surfaces, ground surfaces. And if you click on roof surface, then you will see the attributes of the roof surface, or you click the single features themselves. So you can also click just on the wall surface in order to understand the attributes. For example, noise level could be an attribute of the wall surface, which you want to query or want to make available. We also integrate BIM designs. So the B3DM specification is very flexible in that. So we can also have BIM data, which represents architectural designs in the city. So this is how a part of Berlin should look like in the next years. And also point cloud is very important for us. So the integration of heterogeneous data sets. So not just the buildings, but also point clouds. And here you can see the point cloud represents the vegetation. So it's very easy using a classified point cloud. Just take the vegetation points and enrich your city model with the vegetation objects. Yes, and finally, of course, we can also color. As soon as you have the attributes with the objects, you can do styling. And this is very important, of course, to represent or to visualize the results of a visualization. Okay, so cesium 3D tiles is a really great extension to our CityGML-based open source database, which already existed quite a long time. But now with that cesium extension, we can really bring the models in the web. You can visualize them, you can click them, have the semantics associated with them based on that open source stack. Where is it available? Find it on GitHub. And by the way, on some of these slides, there were also URLs. So this is freely available. Try it out if you want. And also that Berlin model. So this is a freely available application on the web. So just check it out. I don't know how much time I've left. 10 minutes, okay, that's cool. So hopefully it works live. I can show you. Hopefully. So my laptop is not the fastest. So this is that screenshot I showed you. Now I have to put away the mic. Hope you can still hear me. So this is now the point cloud rendered with the buildings. So you can also disable the buildings. Then you just have the point cloud. And yes, as you zoom in, more points are loaded, so it's quite a dense point cloud, and you can see the points are loaded as soon as you zoom in, and if you zoom out, then of course a less number of points is loaded, but still it gives you a quite good view on the vegetation of that green park within Berlin. And yeah, we are using 3D tiles for that. And we can, of course, switch or add the buildings additionally if we want. So it's just another layer, and then you can see we have also the buildings now together with the point cloud. We don't use composite currently, but I think it's a good idea to have that composite tiles within the 3D tile specification. Yes, and if we don't have that, then you can see you can stream really efficiently through Berlin. The buildings are loaded. Excuse me. You can click on the objects. In this example, we don't have the full feature semantics available. This is another demo which you can find on our website. But you can click on the buildings. They know what they are. The reason here is that this entire data set is open data. So you can download the CityGML data set of Berlin and try out with the database your own. And that's the reason why they basically stripped off all the thematic attributes within the open data set. Of course, you can also switch to textured buildings if you like. So this is also easily possible with the 3D tile specification. So we can also stream textured buildings based on GLTF in the background. Still, you can click the buildings and get the attributes. So, yes, and this data set of Berlin was almost done fully automatically. So the buildings were created from a point cloud, having building footprints on the point cloud. There was an algorithm which basically did a best fit approach to identify the building shape. And the texturing is also done fully automatically from oblique imagery. So the costs for building such a model with that detail are quite low nowadays. So it's not really as expensive as it used to be. Yes, and if you also want to see that more high-resolution model, then go to that URL, Business Location Center. So this is the official application from the city of Berlin, and they use it mainly, as I told you, for city marketing. So there is a 2D component, so a 2D map that is implemented with open layers. And there is a nice connection between open layers and cesium. So we can switch to 3D in the cesium view. Now cesium is loaded at the same spot. And then hopefully, also the buildings are loaded. So this data sits on a server in Berlin. It's not in the Amazon cloud. So Amazon cloud and German data is not a perfect match. At least public data, so not private data. Yes, so that's why it takes a while to load. But you can see, and this is the model I did all the screenshots with. And yes. And one example, which I want to show you. So unfortunately, the entire legend here is in German. We will have an English version soon, but currently it's not available in English. So we have plannings within the city. And this one planning I just showed you before. So try to load that now. So this is one part of the city called the EUREF campus, where they try to attract big companies to invest. And I think Oracle wants to have an office there, Siemens. And I hope I can show you how that park will look like. So here, that's the existing buildings loaded. Yeah, let's see whether it finishes. While it's loading, I think we could switch to questions because there's only 5 minutes left. And okay, so here you can see it. So if you have questions, I'm happy. We have 5 minutes left. Yes?
You said you had the cities helping the textures on the buildings?
Yes.
So they provided you the oblique imagery, or?
Yes. Yes. So oblique imagery is acquired regularly, and so the cities have that data, and it can be used. Yeah, these are of course BIM models, so they are done with architectural tools. So you can even have a look inside. There is transparent textures and everything. That's of course not the quality you have for the entire city, but that texturing comes from oblique imagery. And if you zoom in, of course, the resolution gets better. Also, we did that based on 3D tiles in order to reload the texture resolution. Further questions? Yes?
Can you explain more about how you're using the Collada and KML in the pipeline? Do you tile that, or that's just for output to Google Earth?
Yeah, that's mainly for being able to use Google Earth still. Yes. Further questions? Yes. Yes. So you have at least some columns. You have the different floors. You have even doors. The problem is that really going in with the camera is perhaps could be better with cesium currently, but it's not basically an indoor viewer. Yeah. Well, at least you can see something. We stripped off many interior details. So these models originally contained furnitures, tables, even plants and things like that. But if you visualize on a city scale, you don't need these details. So if you would like, or if you want to see more details, then you click on the building and use a BIM browser in order to inspect the building interior. Okay. No more questions? Okay then. Thank you very much for your attention.